Hello everyone, welcome you all to ELD Talent. Today we will be discussing one of the hard problems in the lead code, that is n queens. That is the question number 51. Let's discuss the question first. The n queens puzzle is the problem of placing n queens on an n by n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the n queens placement, where q and dot both indicate a queen and an empty space respectively. Let's understand the given example. Here it is given n is equal to 4, means input is 4. Then we have 4 by 4 chessboard. Let's see the explanation. There exist two distinct solutions to the 4 queens puzzle as shown above. Means the chessboard is 4 by 4 and we need to place 4 queens such that no two queens can attack each other or threaten each other. If we see the output, it has two arrays and it is represented by these two images. If we see the first configuration, they have put the 4 queens such that no two queens can attack each other. If we see the first item in the first array, that is dot q dot dot, it represents how it is placed in the chessboard first row, that is dot queen dot dot. If we see the second item, that is dot 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 queen. By this pattern we can write the output and check the answer. If we see the example second, that is the n is equal to 1, means it is 1 by 1, that is only 1 by 1 chessboard, and output is q. That is the array of array and we have placed q in it. Next, how we will going to discuss the solution. First, we will understand the chessboard, then basic concepts and how rules play out. We will understand the algorithmic concepts. Then by understanding 1 and 2, we will convert these concepts slash our mental model of our understanding into the code. Then we will develop the code solution and test it. At the end, we will summarize whatever we understood and how we implemented. Next, we will understand the chessboard and its basic concepts. Let's understand how queen works. If we place a queen in the bracket or any position, she can attack horizontally right side, horizontally left side, vertically upward, vertically downward, diagonally upside right, diagonally right side down, diagonally left side down, and diagonally upside left. If we understand the rules according to the problem, we need to satisfy these 3 rules. That is, no two queens in the same row, no two queens in the same column, and no two queens on the same diagonal. We can put these first 2 rules such that is every row should have only 1 queen and every column should have only 1 queen. If we see and validate the rules for the given configuration in the image example, we can check such that for the n is equal to 4, for n is equal to 4, we need to put 4 queens in this chessboard. If we see the first row, queen is placed in the third column and she can attack in this first row. Means first rule is satisfied, that is no two queens are placed in the same row. If we see the column, no two queens are placed in the same column. If we see or check the diagonal with respect to this, that is this diagonal and this diagonal, no two queens are placed. So this first placement for the first row, it is satisfying the three rules. If we check with the second row, which is placed in the first column, if we see the columns where she can attack, so no second queen is placed. If we check the row, no two queens are placed. So this placement also satisfies the three rules. For this position, we can also check these diagonals and it satisfies. If we see the third placement, that is on the fourth column and third row, this row is empty, this column no queen is placed, in this diagonal and in this diagonal no queen is placed. So this also satisfied three rules. If we see the fourth position placement, that is second column and fourth row, for this row no queen is placed, for this column also no queen is placed. If we see the if we see the diagonal, no two queens are placed. So we can see that this configuration checks all the rules. If we want to check in the empty chessboard, let's place the queen on the first row, first column, that is 0th row and 0th column. We can say no second queen in this row and no second queen in this column. If we check for the diagonal, we cannot place here. So this row is done. If you go in the first row, we cannot place here second queen, we cannot place here second queen, we can place second queen here. Then this row is gone. For this, diagonals are this and this and this, upside this and this, and column also gone. So if we see in the second row, according to these first two queens, we cannot place the queen. So according to these three rules, we cannot place the queen in this row. So this configuration is not allowed. For checking these conditions, we need to develop the code. Next, for understanding and solving the previous problem we faced, we need to understand the recursion. Recursion is a fundamental concept in computer science where function call itself to solve smaller instances of a problem. How we will apply this for our problem? In n queens problem, recursion will help us explore potential queen placements row by row. So here is the example. We will place the numbers as 0, 1, 2, 3 for columns and 0, 1, 2, 3 for rows. We will place the first queen here, 0th row, 0th column. Then we will check for the first row. So according to the rule, we cannot place here. So we will go next to the second row. or we can say the number first row after the 0th row. Then we cannot place in the first column as well. So according to this position, this column also gone. So we'll place here. So according to this placement, this row also gone. According to this placement, we'll check after placing on this row, we will check these diagonals. This column also gone. So we cannot place here. So recursion will only help to iteratively keep the queens row by row, checking the conditions and go to the next. But currently we have problem that this position is not valid according to the rules. Then we need to understand one more concept, that is backtracking. Now what is backtracking? Backtracking is technique used to solve problems incrementally, abandoning a path as soon as it's determined that it cannot lead to valid solution, according to the configuration we saw last time. How we will apply it in our solution? That is, if placing a queen leads to conflict, backtracking allows us to remove it and try alternative solution. How we will do this? So according to the last configuration, we have put queen here and here. These two rows are gone. For this row, we cannot put here. We cannot put here according to this diagonal. We cannot put here according to this column. We cannot put here according to this column, and we cannot put here according to this diagonal. So we need to remove this. Then according to this position, we will try to go to the next column and put queen here. We will remove this position. And how we will remove this position? By using backtracking. Then we will check here. We cannot put here. We can put here, as according to this column is gone. This diagonal is gone, and this column is gone for this position. This column is gone for this queen. So we can put here. So according to, by using recursion, we can go to next row, but this column also gone, this column gone, this row gone, this diagonal gone for this condition, and this column also gone for this queen. So this placement is also wrong. Then by using backtracking, we will erase all this. Then we will start with first column, 0th row and first column. So this we will do by using backtracking, and how to implement it in the code we will see in the while development of the code. Next, we will develop the code. Let's move towards lead code platform. Let's start the coding. For step 1, we will initialize the constant parameters, that is initialization. We will initialize the chessboard, that is array.from with the length n. By using function, we will initialize one more array as each element with the length n and fill it with empty string that is dot. Then we will initialize the empty array for storing the result configuration or valid configurations. Then we will initialize the flags we will be using. We will create a new instance of set for storing the unique values into it. We will create a flag diagonal1 and diagonal2 with instance of new set. Same for storing the unique value. Then we will initialize or call the function that is recursive function with the initial value of the row that is 0. That will be step 2. Step 3. We'll be writing this solution or this function that is solve constant solve with argument row for each row. We will iterate through the column by using for loop. That will be step 4. For loop with column 0 as starting point until it is the length of the array. We will increment it one by one. Then as step 4 or 5, for this configuration we'll put at this row and column, that is first row and first column, we'll put the queen. We will update the flags that we initialized at the first step, that is column used dot add the column diagonal 1, that is row plus column diagonal 2. Let's add this. Same with add row minus column after adding the first configuration or first position in the board. We will recursively call the solve function, that is step 6, with row plus 1. Now remember, we are at 0th row and 0th column. We'll iteratively call the row plus 1, that is first row after the 0th row. Then again we'll come here, Then we will come into the for loop for the first row. Now we will check the conditions or flags for the first row. I will understand this, that is how we created board and how we are using this problem solution or approach in the slide. So let's go back to the slides for better understanding. So how we created the empty board, that is empty chessboard. We create a board by assuming n is equal to 4, that is 4 elements with 4 length. Then for each element we created new array with length n, that is 4, which is first empty. Then for each item of each array we added dot, that is empty string, empty position. So if we see the initialization of the board, this array dot from with a length n creates empty array with length of 4. This next function will create new array for each element with length n, that is 4, and this fill function will add each position of this array as string with dot, that is represented by empty. Next, how we update the flags and how it is responsible for handling the rules or conditions. First we initialized or created the flags. Let's understand it by representing in the chessboard. First we created the flags, then we started the function with 0 row. Then by using for loop we went in the 0th column, and then we put this position 0 row and 0 column q, means here. Okay, now we updated the flags, that is column used dot add column, means column 0 is added. Then diagonal 1 row plus column means 0 plus 0, that is 0 is added. For diagonal 2 row minus 1 row minus column, that is 0 minus 0, that is also 0, this is added. Next what we do, after adding this position we went to the next row, that is row plus 1, that is 0 plus 1, that is 1. Then we will go again in the same for loop for iterating on the columns, means we went into the first row. Here we will check the conditions, like if column has column, that is if this column is used. Let's check. Let's write down, if column used has given column, means 0th column, yes, then we need to continue for it. Okay, means this is not valid. Then we will iterate to first column. First column, we need to same check for the columns. So what is the column here? Column 1. If we check the column 1 here, with like column has 1, so it get passed for this condition. Then check with the diagonal 1. We need to check with the 2 diagonals. Same as this flag, we need to add the condition for these two. That is, if diagonal 1 dot has row plus column, or diagonal 2 dot has row minus column, then we need to continue. Don't operate with these lines. How it is checking it? So let's check with this position. For this position, it checks with the column used 1, it gets passed. Next, it check with the diagonal 1, that is row plus column. What will be the condition here? It will be 1 plus 1, that is 2. So it 2 is not in the diagonal 1, it get also passed. Then we will check with the diagonal 2, that is row minus column, that is 1 minus 1, that will be 0. So this condition also passed, so it will get continued. It will get continued to the second column. So this position also not fit here. Here it will check again with this if condition, that is column has this column, second column. Then for the, this is first column, this is second column. Then if we check if the second column is there, it gets passed. If we check with the diagonal 1, that is 1 plus 2, that is 3. We check if diagonal 1 has 3, it is no, it is also passed. If we check diagonal 2, that is 1 minus 2, that is minus 1, it is also passed. So we can, this is passed with this if condition, and then we can add this position in the board again, that is first row and second column. That is, we can add the queen here. Next, we'll iterate to the next row by going on this line, that is row plus 1. Previously it was 1, now it will be 1 plus 1, that is 2. Now we are in this row. Here we'll check again. Now for this, remember, we have added this configurations or flags here. So what is new value? What are the new values in column D1 and D2? That is, first it was 0 0 0, then it is column 2, diagonal 1 is 1 minus 2, that is 1 plus 2, that is 3, then 1 minus 2, that is minus 1. Next, for this position, this column is gone, that is 0, it has it, so it is, we go to next column, that is column 1. Here if we see the D1, see the D1, that is diagonal 1 row plus 1, that is 2 plus 1 3, so it has 3. We cannot put here also. Then we check with this position, that is column 2, it has column 2, we cannot put here as well. If we see here, if we check with the column does not have this, so we can put. But if we see the diagonal one, that is 2 plus 3, that is 5, it does not have. But with the third condition, that's diagonal 2 row minus column, this 2 minus 3 minus 1, it is checked in this, like it has minus 1, so you cannot put the queen here as well. Now we have done with all the columns. Then it will come out of this loop of solve, that is recursive function. Then what we need to do? We need to backtrack and remove this position, as this position is not validate the rules. So how we do it? By removing the flags of that value, that is column used dot delete column, same diagonal 1 dot delete row plus column, diagonal 2 dot delete row minus column. Now this will satisfy the recursive function as well as backtracking function, and we will move forward to the next position, that is next column. Now this will iterate through all the rows and all the columns. It will come out of this loop, and at last we need to come out of this solution and add the configurations. We'll do it using the step. What is the step now? Here. First, here is the step 7. Here is step 8. That is, if we are out of the row, that is row is equal to n, then result dot push the given board configuration, board dot map with row each row dot join and then return. Here it will return the result with all the configurations. Then now we need to return the result and test the solution. So before it, let's understand this line. Now we continued with the code. Now we will understand the line, that is how to add a valid configuration of the board to the result array. First we have initialized the result, that is empty array. Then after going to the logic, we added the valid configuration in the board like this, but according to the problem and its example given, we need to convert it into the representation of the output. So for every this array, we converted it to the string, that is dot q dot dot, and for converting into this we used this function, that is here for each row we'll used row dot join, that is for each row is converted into array and I represent as a new string, and it is done for each row, and this board configuration is added to the result. Now let's continue with testing. Let's test our code. Let's run it. See, it has some errors. Let's debug it. That is diagonal.add. Let's write row here. Test again. Something is wrong. Let's debug it. So how can we debug this? We need to add, like after resolving this issue, like coming out of the solve function and checking all the columns, we need to delete or at that position row and column, need to update the position as empty and test again. That is run. Now all the tests are passed. Then we will submit it. See, now this solution is passed and submitted successfully. Now, as we tested the code successfully, we will summarize whatever we understood. We understood how to apply concepts and develop logic and respective code. We understood recursive function and applied it to iterate through each row. We understood for loop and applied it to iterate through each column. We understood JavaScript and applied its various functions for the objects and arrays. Also for the flags. We understood backtracking and applied it in combination with deleting and updating the flags. We understood how to debug the code and resolve it for possible mistakes in the code. And as a cumulative of all, as a result of above, we successfully solved the n-queens problem. Thank you for watching the video on my explanation. Thank you very much.